and I'll be telling you about this review paper that I've been putting it together with some students. So most of you probably know what ecohydrology is. It's the study of the link between ecosystems and water. But when I say tropical ecohydrology, maybe some of you think of a nice tropical beach in the Caribbean, or most likely the rainforest. But páramos, which are tundra-like ecosystems at high elevation in the Andes, or Kenyan savannas are also examples of tropical ecosystems. But however different they might look, they all have very similar threats. Currently have linked to them. So deforestation for grazing or agriculture have impacts not only on the carbon uptake of these ecosystems, but also on the water cycle, because it will impact runoff as well as transpiration. Secondary vegetation and invasive species tend to transpire more than some of the plants they're replacing, and will also impact runoff and stream flow. And finally, climate change is impacting those ecosystems, not just because of changes in temperature, but also because the rainfall patterns are changing drastically. So there are many links between ecology and hydrology that those ecosystems are, that ecology is looking at. Fall water, for example, is really important for a lot of those mountain ecosystems at high elevation. Nutrient cycling is being changed because of the changes in runoff that I was just telling you about. And basically those two things are linked to a lack of understanding what small-scale changes can do at larger scales. And this is especially true in the tropics because we're missing a lot of instruments in the ground, because a lot of those areas are very remote. So there are also a lot of new research tools that we've been able to use. Multiscalar techniques like wavelength analysis allow us to kind of decompose a signal into the different components coming into it. Remote sensing has obviously been a really useful window into those some of those very remote areas, and also have been able to show us what larger scale patterns look like, both temporally and spatially. And stable isotopes of water are the best tracer, some might say, to link water and plants, because the chemical and physical processes happening both in the soil and in the plants will have an impact on the ratio of heavy to light isotopes. And finally, social medias have been a great way for ecohydrologists to kind of reach out to new audiences. So, for example, the tweeting trees of the Tree Watch network, I don't know if anyone knows about this, have kind of brought plant physiology to a lot of new people. One final thing is that a lot of this research is actually happening in South America or in Southeast Asia, and there really isn't that much going on in Africa. And so this is sort of the new frontier for tropical ecohydrology. As I was saying, all of this research is kind of coming together into this review paper that is led only by students. Where can you find them? All at the bar. And it should be coming out this spring. And we actually all met at the AGU Trapman conference this summer, which, if you haven't attended one, I really recommend it, because it's a great way of meeting senior scientists and younger scientists with who you can collaborate later. And you can also get to do really cool field work, so I highly recommend it.